Hello students and welcome to today's video tutorial. In this video tutorial, I will explain the basic concepts of routing information protocol such as routing metric, the process of sharing routing information, and RIP configuration commands which are used for configuring the RIP in Packet Tracer. Today, an internet can be so large that one routing protocol cannot handle the task of updating the routing tables of all routers. For this reason, Internet is divided into autonomous systems. An autonomous system is a group of networks and routers under the authority of a single administration. Routing inside the autonomous system is referred to as intra-domain routing. Routing between the autonomous system is referred to as inter-domain routing. Each autonomous system can choose one or more intra-domain routing protocols to handle routing inside the autonomous system. RIP, Routing Information Protocol. It is an intra-domain routing protocol used inside the autonomous system. It is very simple protocol based on distance vector routing. RIP implements distance vector routing directly with some considerations. Let us see what are those considerations. First, in an autonomous system, we are dealing with the routers and the networks. The routers have routing tables, networks do not. Second consideration, the destination in the routing table is the network, which means that the first column of the routing table defines the network address. Third consideration is the metric. The metric used by RIP is very simple, that is hop count. In this, the distance is defined as the number of links to reach to the destination. For this reason, the metric in RIP is called as a hop count. Fourth consideration, infinity. Infinity is defined as 16 in RIP protocol, which means that any route in an autonomous system using RIP cannot have more than 15 hops. Next consideration is the next node column defines the address of the router to which the packet is to be sent to reach to its destination. As you can see in the diagram, it shows the routing table of router R1. Let us see what are the commands and how to configure the RIP protocol. In a RIP-enabled network, every router broadcasts its entire RIP table to its adjacent routers in each 30 seconds. When a router receives neighbor's RIP table, it updates its own routing table from the received information and then broadcasts the updated routing table to the adjacent routers. The two primary commands which are used to configure the RIP are router RIP. This command selects RIP as the routing protocol. Second command, network address. This command advertises the network address to which the router is directly connected. The commands to verify the RIP configurations are as follows: show IP protocol, show IP route, debug IP RIP. Let us see with the help of an example how to configure the RIP protocol in Packet Tracer. By looking at this topology, we can come to know that this topology it consists of four routers: router R1, R2, R3 and R4. Router R1 advertises its routing table to router R2 and router R3 because they are directly connected to it. Similarly, router R1 directly connects network 30 and network 20. Router R2 directly connects network 30 and network 40. Router R3 directly connects network 20 and network 10, whereas router R4 directly connects network 40 and network 50. So let us see how to configure this topology for implementing RIP protocol. The commands for configuring the RIP protocol on router R1 are: to configure the RIP protocol on router R1, we have to go to the configuration mode of the router. Once we are in the configuration mode of the router R1, we can configure the RIP protocol by entering the command router RIP. This command will enable the RIP protocol on router R1. Next task is to advertise the networks to which router R1 is directly connected. For that, we use the network command. As you can see in the diagram, router R1 is directly connected to network 30 and network 20. So therefore, we need to advertise these two networks. This can be done by entering the command network 20.0.0.0 and one more time network 30.0.0.0. That's all for today's video tutorial. Thank you.